All right, so here's the program that you wrote for the spaceship interface. Let's go ahead and break it down into its pieces. Now, there are three main parts of this program. The first part is in the beginning, where there's this int, and it says switch state equals 0. So what this is doing is what's called declaring a variable. So basically, this is saying that I want the computer program to remember something, and I'm going to call that something switch state. And the switch state is either going to be an integer, so 0, 1, 2, 3, 4, 5, a whole number. And in this case, you're just setting it to 0 just to give it a value to start with. So you've named this piece of information. All right, so now there's a part of the computer or the Arduino's memory that is storing onto this 0, and it's referring to the 0 as the switch state. Now there's this setup part. Don't worry about the void, what that means yet, but setup is a function here, and this is just run once when the program is first started up on the Arduino. And this is basically saying in this case, what each pin is going to be doing. So we've got, we're setting pin modes. So these are the little holes on your Arduino, and they're numbered. And this is saying that pin 3 is going to be an output, pin 4 is going to be an output, pin 5 is going to be an output, and pin 2 is going to be an input. That means it's looking for a signal from pin 2. Pin 3, 4, and 5 are outputs. Those, the Arduino, if given the command, would put a 5-volt current, because that's all it can do. It can do 0 volts, which was nothing, which is the low state, or it can do 5 volts, which is the high state. Next is the loop function. The loop function, this is what it's going to do. It's going to do whatever is inside the loop function for while the Arduino is running, and it's going to repeat this over and over and over again. So that's why it's called loop, because it's just going to keep on repeating whatever in this part of the program. So this one here is, we're referring back to our switch state variable. So right here, we set this switch state and we set it equal to 0. Now we want to digital read, and this is pin 2. So remember we set pin mode 2 as input, and now this is saying, okay, look at the value of pin 2. All right. If the switch state is low, and that means that there's no voltage coming through pin 2. If that switch state is low, then you're going to turn on pin 3, put a 5-volt current out pin 3, and that's what you should have your green LED hooked up to. And then put no set pin 4 and pin 5, the two red LEDs, to low value or no voltage. So this should illuminate the green LED and have the two red LEDs off. Now, if it does a digital read, if it looks at the switch state, the state of pin 2, and the switch state equals high, right, that means that this would not be true. So it's only going to do this part if the switch state is low. So if there's any other condition, meaning if the switch state is high, it's going to follow this else path. And the else path, if we look at this bracket to this bracket, this is what it's going to do if the switch state is not low. So in other words, if the button is pressed. So if the button is pressed, it's going to turn the green LED off, right? It's in a digital write pin 3 to low, which means turn the green LED off. And it's going to turn on the red LED hooked into pin 5, right? The one in pin 4 will still be low, then the one in pin 5 will be high. So it's going to turn this one on, and it's going to wait 250 milliseconds, which is a quarter of a second, and then it's going to turn pin 4 on high and turn pin 5 to low. So it's flipping it around. So it's flashing the other LED on and turning the one that was on, turning that off, and waiting for a quarter of a second. And then it's going to go back up to the top. It's going to examine the switch state. If the button is still pressed, then this is not going to be true. It's going to be high. So it's not going to do any of this. It's going to do the else condition. So it'll follow all of these here. Now if it repeats and you let go of the switch, then the switch state will equal 0. Then it's going to do the commands that are within these brackets. So it'll go ahead and turn the red LEDs off and turn the green LED back on. Some of you last week figured out that you can change this delay, and that will alter the rate at which the lights flash. Now, you could go ahead and add another command below this line, and you could add another flash state. Let's say you want both of them to be on at the same time. All right, you could add in a digital write, and you could say digital write to pin 4. You could say high, and then if you want them both on at the same time, you could digital write to pin 5 and turn that to high as well. And at the end of each line, you're going to need a semicolon. And then I accidentally got rid of my curly bracket, so I'll go ahead and close that up. We're going to want to, it could cycle through this very quickly, so we want this to stay on long enough for us to see it. So go ahead and put a delay in here, and you do 100 milliseconds, and then put a colon in there. All right, so you try that, now you should have a different flash pattern. See if you can make your own flash pattern. Now, if you wanted to add another LED to play with in the flash pattern, you would first of all have to declare that pin up in the setup. So if you wanted to have another output, right, you would have to declare pin mode, and let's say pin 6, and declare that as output, and put a colon at the end of the line. Now you could write a command down here to digital write to pin 6 and include that in your flash pattern. If you wanted to add another button and have another button that controls something, you would first of all have to declare another variable to store the state of that button. Remember that this variable, switch state, is storing the value of pin 2, which is what we have the first button hooked up to. So we'd have to declare an integer switch state, let's call it switch 2 state, and you could call it whatever you like, just something that is going to make sense so that when you're reading your program you know what it's referring to. You call that switch 2 state, and put a colon up there. Now it has another variable that it's holding on to, and we need to figure out which pin we're going to hook switch 2 up to. So we could say, looks like 7 is available, so we'll go ahead and do pin 7, and we'll make pin 7, we'll make that an input, because we're going to want to monitor pin 7. All right, now down here, you could add another if-else command down here, and we could say if switch 2 state equals low, do one thing, else do another. Why don't you, I'm going to leave it up to you a little bit for figuring out how to put that in there. Remember that when you add your other if-else command, you're going to want to do something like this, where you do if switch 2 state is equal to, in here you'll need 2 equals to, well, before that we need to digital read it. So we can put up here with this one, we'll go to switch to state. We want to get a digital read for whatever pin we put this in. I think it was 7, so it's going to read pin 7. So down here we could do if switch to state is equal to low, and then open up a curly bracket, and you could have it do something here. Why don't you start simple? Maybe just turn on a separate LED, turn on one of the LEDs. It's up to you. Make sure you put your colons at the end of the lines, and make sure you close out your curly brackets, and go ahead and see if you can add in another button to perform another function.